All right, so looking at 1-6, again, I don't think it's that difficult. There's definitely some vocabulary that you need to make yourself aware of. Um, Domain, range, mapping, also independent and dependent variables. Um, does anybody have any questions? I know we worked without the worksheet yesterday, and then I finally got it to you. Um, but let's just take a quick look at relations here. All right, just to make sure. All right, and just to show you how simple it is. All right, express each relation as a table. All right, so all we're doing is we're converting this table, or not this table, but these ordered pairs into a table and into a graph. So all you're actually doing is -1, -1, 1, 1, 2, 1, and 3, 2. That's all there was to it. That's all you're doing. They're just represented different ways. And then, of course, all you're doing is you're graphing -1, -1, 1, 1, 2, 1, and 3, 2. And that's the end. All right. Now, just to make sure, let's go ahead and do number 3. 3, -2, 1, 0, -2, 4, 3, 1, 3, -2, less 1, 0, -2, 4, 3, 1. All right. Does anybody have any questions with that? All right. Now, identifying independent and dependent variables. This is a little bit tricky for kids sometimes, but let's look at number 4. The more hours Maribel works at her job, the larger her paycheck becomes. So what depends on the other? Her paycheck depends upon the number of hours that she works. So her paycheck is the what? Dependent. And the number of hours that she works is the what? Independent. The more hours you work, the more money you make. All right. Number 5. Increasing the price of an item decreases the amount of people willing to buy it. All right, that's basic supply and demand. All right, what that means is the higher the price, the fewer people can buy it. All right, that's why you want to make your price as good as you possibly can so you can attract more people to buy it. All right, and generally that means that the price is what? The independent, right? And the amount of people willing to buy it is the what? Dependent. All right? All right. Now, let's just do, in the next little worksheet here, let's just do a mapping because I just feel good about everything else. All right? So when you're doing a mapping, we used to just make 2 ovals. All right? I don't care what. If you want to make a rectangle, more power to you. All right? Now, this represented the domain. This represents the what? The range. Now, we used to always put things in numerical order, but this book says, does that really matter? No, I'm just doing it the way I used to do it. All right, we would write things in numerical order. So I would say -2, then -1, then 3, then 4. That's how I would write it. And then I would write the range in order also. And the range would be -2, 1, 3. Wow, is that right? All right. And then 4 maps to what? 4 maps to 3, right? So here to here, -1 goes maps to 4. 3 maps to -2. And -2 maps to 1. So again, that's not a big deal. Alright, we're probably not going to ever see that. Alright? Because it's just a faster way of writing things. Alright, that's all. I'm pretty comfortable with you guys graphing the points, so that shouldn't have been a big deal. Describe what's happening in the graph. The graph below represents the height of a tsunami as it travels across the ocean. Alright, tell me. That's all you have to do. The height is increasing over time. However, I'm not real comfortable with this right here, because that makes it seems like it's always, yeah, that's not true. Alright, to me, it would almost have to look something like this. That's to me what it would look like, right? Because at some point it reaches its highest point, and then at some point it has to what? Go back down to 0. Alright? The graph below represents a student taking an exam. Alright, and again, I don't like the end here, because it makes it seem as if there's an infinite number of questions. Alright, at some point, this should be a solid dot, in my opinion. Representing what? The fact that it's over. You reached the last question. Alright? Now, if you wanted to talk about this real quick, because that's a theme of the new SATs, is being able to describe graphs. Alright? In this particular problem, we could say, you know, you're answering questions, right? Then what happens here, though? But why could it stay the same when you're answering? You could be taking a break, or you could be talking about it or thinking about the question. You don't know exactly how to do the problem, so you had to think about it. All right? And of course, the same principle here. All right? Express the relation shown in each table, mapping, or graph as a set of ordered pairs. So all they wanted you to do here was, right? That's the ordered pair. So this would be, does everybody see what I'm doing, right? Just because I'm being lazy, right? That would be the ordered pairs. That's all you had to do, right? Now for the mapping, you would say what? 9, 5, and what? 9, 3, -6, -5, 4, 3, 8, -5, and 8, 7. Does everybody agree with that? But I told you it's very simple. Very, very simple. On the word problem, did anybody see anything that was just like too tricky? Yes, son.
Oh, wait,
Everybody's good now? All right, does everybody agree that's kind of easy?
yeah.
Right, but if you don't know the vocabulary, you just are not going to be able to do it. All right, so I'm going to ask you questions about independent and dependent. I'm going to ask you questions about domain and range. I'm going to ask you questions about plotting points, using a table, probably not a mapping. All right, we just don't use it. All right, but outside of that, I thought it's very easy, very, very easy. All right, now let's go into today's assignment. And I think today's assignment is 1-7. All right. Again, today I feel it's just super easy if you know a definition. All right. Today we're going to talk about functions. All right. Now, again, right, very basic definition of a function. All right, and it says something like this. All right. If a relation is a function, all right, if a relation is a function, all of the x values will be different. All of the x values will be different. In other words, for every x, there is a unique y. All right? For every x, there is a single y value. Everybody good with this? All right. Now, just to show you how simple it is, look at question number 1. All right. -6 is to -4. Does -6 have one value? Yes. Does -2 have one value? Does 1 have? And does 3 have? Yes. So is that a function? That's a function. All right. It's really and truly that simple. All right. Every x has only one y value. All right. Is 2 a function? Yes, because, well, let's see. 5 goes to 4. 2 goes to 1. So far, so good, right? 0 goes to -2. And -3 goes to 1. Now, listen to what I'm saying. Every x has to go to a single y value. All right, to a single y value. So this is a function. All right, now let me give you an example of what's not a function. Number 3. Everybody see what I'm saying? Yeah. This x value has what? 2 y values. So that's not a function. All right. Now, again, listen, when you go to high school, functions are so important that they actually named a course, analysis of functions. All right, otherwise known as pre-calculus. But again, there are some restrictions that they put on the relations to make them functions, and it's very important. All right, right now we're just knowing the basics, so that's essentially all you have to know. All right, to determine if a relation is a function, all you have to do is look at the x values. If the x values are all different, you're good. All right, if the x value is used twice, it's no good. All right, so looking at number 4, all you have to do is look in this column right here. Are any of the numbers repeated? No, so that is a function. That's it. That's how simple. Number 5, you're looking here again. Are any of the x values repeated? Yes. Yes, so that would be not a function. That's it, guys. It's really simple. All you yes or no, I don't care. All right. Number 6, again, we're looking here. 3's repeat, so it's not a function. All right, so those were the mappings. Then you did the ordered pairs. Now we're going to do the, we did the mapping, the table. Now we're going to do the ordered pairs. So on the ordered pairs, all you're doing is highlighting the x's. Are the x's different? Yes. So that will be yes, that's a function. All right, look at number 8. All right, all of these are different. No. Nope, they're not. 6 is the same, so that's no. All right. Now, I'm a little surprised that they have question 9 and 10 because that's kind of what we're getting into, not next week, but the following week, is we're going to start graphing lines. This, what I want everybody to write down next to it is, this is a line, right? And this particular line, I want you to say is yes, it's a function. And again, y equals 11 is an equation of a line. So that would be yes. All right. And again, I don't want you to worry about that. You can kind of put a little star by that. And in 2 weeks, I'll be able to give you why those are a line. All right. But right now, we haven't really studied graphs of lines. All right. Now, number 11, they're drawing a line. All right. Now, let me give you the explanation that I would like for you to know about lines. All right. We say if you have a graph, if you draw vertical lines, and the vertical lines cross in one spot, then it's a function. All right, so let me give you an example. So 11, look right here. So I'm going to draw the vertical lines, and you see if you understand what I'm saying. So here's a vertical line. So how many times does that cross? Once. So far so good, right? Yes. So if I draw this vertical line here, is it still a function? It's called the vertical line test. All right? If I draw vertical lines and it only hits the graph in one spot, then yes, it is a function. All right? Now let's look at question 13. Hold on one second, I promise you. Look at 13. Draw a vertical line. Is that a function? No, because this x value right here has two y values associated with it. Does that make sense? Right? So all you have to do to determine if you have a graph that's a function is draw vertical lines. When you draw vertical lines and it crosses at more than one spot, then it's not a function. All right? One more second, guys, then I'll let you ask me. All right, so now on number 12. So far, is this a function? So far. Yes, because every time I draw a vertical line, it only hits it at what? One spot. So far, good. And then all of a sudden I try this. Right. This x coordinate right here has what? Two y coordinates. So it only has to occur once, and it's not a function. Is everybody good with that?
Yes.
All right. So this one's no. All right. Now there were 3 questions. Okay. I want to go ahead and answer those. Reagan, did I answer your question?
Yeah.
All right. What about you, buddy?
So how come number 12 has dots, but 13 and 11?
That's actually a very good question. So here's what I'm trying to tell you. So number 12 would be like you're just plotting points. You hear me? Whereas 11 and 13 are actually equations. All right? This is called a line. This, number 13, is called a parabola. All right? It's called a parabola. All right? When you take Algebra 2, you will know that that's x minus h is equal to a times y minus k squared. Actually, I made a mistake. The a is over here. All right, so that's the equation of that parabola. All right, that would be the general form. All right, so as you progress, you will learn the difference between a line, between a parabola, between a cubic, between a square root. There's all different types of functions that you will become aware of. All right, right now, listen to me. You are simply at the basics. All right, and this is why it's so important to understand right now what I'm telling you. If you understand the basics, the complex is simple. All right, yeah.
I got confused with 11 and 13. 13, I get it because it's touching like
Right.
2 and x can't or the y value.
Yep.
But for number 11, when you drew the line down, it's touching 2 arrows. So how is that?
What do you mean it's touching 2
Like,
arrows?
okay, so like the first line on my right side,
Okay.
there's a line going like the diagonal and then like straight like across the horizon.
Okay, so what I want to do is this. As I move this, see it's moving, right? Is it intersecting the graph at more than one spot?
No.
Then it's a function.
Okay.
Right, that's all we're doing. Except, which is actually kind of nice about the iPad. I just get more comfortable with the iPad. The demonstration, right? That's all that means. The vertical line test is you're just drawing every single vertical line, which is not possible. But now I can kind of show you that as long as I hit the graph only at one spot, then it's a function.
Okay.
right? Whereas over on the other one, right, exactly. On the other one, over here, as I slide it left and right, it crosses. All right. It's really, truly that simple. All right, really simple. That's why I tell everybody, if you do the work, it's really easy. All right. Now, the next one is honestly one of the most important lessons you learn all year. All right. It's called functional notation. All right. It's called functional notation, and it is on every standardized test. The Jesuit entrance exam last year was huge on this. All right. So your entrance exams into private schools want you to understand functional notation. All right. Now, does everybody understand, which we have not done a lot of, two variable equations? Right. We've always had x, or in the last chapter we saw that every equation might have several variables. All right. But in this algebra class, we're primarily going to focus on equations with what? Two variables, an x and a y. All right. And x is the domain, y is the range, x is the independent variable, and y is the what? Dependent. Now, normally you would write it like this, guys. Y equals 3x plus 2. And I really just want you to listen to me. Y equals, I don't want you to do that on your own paper. Just pay attention. I promise it's much better to listen to me right now. All right. Now, why do you think they changed the notation from y equals 3x plus 2 to f of x and g of x? Well, the main reason is sometimes we're going to be discussing two graphs at once. And if I label them y and y, can you tell the difference? No. So they had to find a notation that you could distinguish between two graphs that you're looking at. So we just chose what? F and G, correct? Now, let me make sure you understand this, and listen carefully now. F of x and y are the same. All right? G of x and y are what? The same. You can interchange g of x and y. They mean exactly the same thing. So, for question 14, f of 4, that just means y equals. All right, listen to me now. All right, I promise there's a bunch of questions. I need you listening. Concentrate on what I'm saying. This means, for number 14, y equals what when x equals 4? You don't have to write that down because I'm going to do it. You're just saying it with me because train your brain. That's what you're doing. All right? What does 16 ask? Y equals what when what? All right, 18. Y equals what when? Now, this x value goes in what function? The f or the g?
The
F. This goes into what function? That's how simple it is. I don't understand why people make it so difficult. All right? Now, again, I'm going to go back just to make sure, because it's been so many, every year people get all confused, and I just don't understand. That's what I'm saying. Concentrate on what I'm trying to tell you. Honestly, I'm not exaggerating. This is one of the most important things you learn all year long. And it's what? Simple. But for some reason, kids don't listen, and they try to make it harder, or they're not understanding what I'm saying. This, inside the parentheses, represents the what? X. What's outside the parentheses represents the y. So when somebody says f of 4, all that means is you're finding the y value when the x value is 4. and you plug 4 in to whatever function they're talking about. So in this case, f of 4 means to plug 4 in for that x. And tell me what the answer is. 14. And I'm telling you, honestly, it's that simple. And every single year, I don't understand it. I don't understand what you're not seeing. And if you're not seeing something, I'm convinced you're just not listening to me. All right? Now, I'm going to go through all of these problems right here. And some of you are going to go, what? Because you're not listening. All right? I don't want to work it all out. I want to practice mental math. All right? You should be able to look at this and tell me the answer. Every one of these. All right? So, now, if you heard me, we can zip through this. All right? And it's super simple. All right? So now, back to business here. F of 4. All right? Again, just to make sure you're hearing me, what am I looking for? I'm looking for the when the
X
is
4.
That's it. That's how you say that. What's the y when the x is 4? All right? Inside the parentheses is the x value. All right? So, f of 4 we said was what? 14. Now, not to confuse you, but look up. Here is another way of writing that. Right? That's the ordered pair that was created. That's it. That's the ordered pair that was created. All right? No, here is the answer. Now, let me explain to you. This is a better answer than y equals 14. Why is that a better answer? Why is this a better answer than just saying y is 14? Because you don't know what the x value is that corresponds to the y value. Does everybody hear me? So if somebody says to you y equals 14, how good is that? It's no good. Because why? You don't know what x value corresponds to that 14. But if somebody says f of 4 equals 14, you know what? The x coordinate and the what? Y coordinate, and not just the y coordinate. Is everybody happy with that? All right. So now, be careful. F of negative 2. Negative 4. Is everybody happy? Now you can write it down. All right? Just the mental math. All right? Now, be careful. G of negative 3. Hold on a minute. What did you plug in for x? So what's 3 times negative 2?
It's negative 6.
Plus 2. Okay? Now, listen, if you're using your calculator, you're making a mistake. Okay? So what is G of negative 3?
It's negative 12. It's negative 7.
You guys are crazy.
Negative 9 plus
Guys,
2.
it's negative 5. 3 times
Are you
3.
kidding?
Yeah.
I haven't heard the answer yet.
Negative 12.
It's
Look, wouldn't it be positive 3?
Why is it positive?
No, negative 4.
Freddie.
Wouldn't it be positive? 6.
Yes, it's 6.
No, because if it's an
Gosh,
exponent, it's
awful.
Negative 9 plus 2.
No. What?
What?
You got it right. I said negative.
Said negative.
How? Wait, but how is it positive? No, how isn't it negative?
Because the negative times a
nine.
positive.
Okay, first of all, where is negative 3 going into what function?
Oh, we're looking at the other one. Oh.
Yeah, so no.
I was looking at that. I was
So,
so confused.
wait.
Okay, hold up. Go.
Alright, so it's
Now understand, listen to me. You know without any doubt I'm what? I'm correct. So don't try to correct me. All right, let me just make that clear. You need to correct yourself.
Can I ask, can you correct me?
Oh, absolutely. I'm very good at that.
So, negative 3 times negative 3 is 9. And then, since it's minus 3, I thought it was 6.
It's not -3.
It's
minus
plus 2.
-3. So it would be +3.
Oh.
She's right. Watch. G of -3 is equal to -3 squared minus -3.
And then you do plus.
That's right. So that becomes 9 plus 3. All right. So now listen, your mental math will fail you if you're not careful with the negatives. All right. And this is the #1 mistake. And honestly, this right here is on most standardized tests. And they always put in a what? Negative. Just because they know kids go quickly with their mental math. And they actually use small numbers so you won't use your calculator. Is everybody with me on that? All right. And that way you'll just make the mistake in thinking that you're absolutely correct. All right. That's why I try to tell kids all the time. You know, you go in and take a standardized test and you think you're right. But I'm telling you, the standardized tests are designed for thinkers. So if you're not willing to think through the test, your score is way lower than it should be. Way lower. All right? Because you're a robot. You just look at something, circle the thing, go on to the next question. And they're designed for people who like to think, especially the ERBs. All right? Especially the ERBs. All right? So now, number 20. Let's talk about this. So, what I'll do for number 20 is I'll just see who thinks they know what the answer is. What do you think? Very, very good. Very nice. Because what? You find f of 2, right? And then you just do what?
Add 1.
Add 1. That's all that means. And I try to tell kids, you're literally just following directions. That's all you're doing. You're following directions. You plug 2 into the f function, and then you add 1. Just like down here, we're going to plug what? 2 into the
G.
and then what?
Right, -2.
And then subtract 2. All right? So here we go. If I plug 2 into the g function, I get what? 4 minus,
2.
which is 2. 2 minus 2 is?
0.
Yes. If you got 0, pat yourself on the back. You kind of understand what I'm talking about. What? Go ahead.
Can you write out how you got the answer for
Yeah.
Well, for anybody else, I would, James, but for you, this is going to be easy. Seriously, I'm not kidding. You're just not seeing it. So which one are you having trouble with? Seriously.
20.
All right. So tell me, you plugged 2 in for x, and what did you get when you plugged 2 in for x? Shh. I want to hear James.
So I'm plug 2 in for x. It's 6.
How did you get that?
2 times 3.
Oh yeah, but now you're just not seeing this, buddy. Because I have so much written up here. Look right here. The whole function is 3x plus 2, though. Were you not seeing the plus 2 there?
No, right.
You see what I'm saying, right? So plug 2 in, and what do you get? Now.
Oh, yeah, that one's easy. But
No, I'm asking you a question, but you didn't answer my question. I said, if you plug 2 in, what do you get?
if you plug 2 in, you get 8.
Yes. And then plus 1, we said was not. Right? You hear me? Hold on. Let me knock out James. Go.
Oh, I understand it now.
All right,
You
good.
do the
Go ahead. No, you're fine now. I know it'll be easy. All right? You have to see the whole function. All right? Go.
I believe you said you got a 22.
All right, so plug 2 in. All right, now let's say you're having a little issue. You're going to plug 2 in, so I'm going to write the whole thing out. G of 2 is equal to 2 squared minus 2. Hold up for a second. Hold up. Does everybody see that? So that's 4 minus 2 is 2, right? So listen, finish up.
You said you got 0.
Finish up this one and 1 point on the next worksheet. All right, finish them up. Come see me if you're having trouble, especially at lunch. I'll help you.